Alright, this is for a review for the periodic table / atomic test. Okay, you should have a periodic table that's marked up. A few things to remember. Those colors that you use help designate the groups. Hydrogen does not belong with the group, that's why it's black. Group 1 are called the alkali metals. They have a +1 charge and they have one valence electron. It's easier for groups 1, 2, and 3 to lose electrons than it is for them to gain them. Okay? Their atomic radius will also be larger than groups 5, 6, and 7. Okay. Group 2, alkaline earth. 2 words, group 2. +2 charge, 2 valence electrons. Group 3 is called the boron family. +3 charge, 3 valence electrons. Group 4 is halfway in between groups 1 to 8. So group 4 is called the carbon family. We say they have 4 valence electrons, and generally we're going to say that they share electrons. We will find out later there's a few exceptions in that group, but for right now, that's what you're going to believe. Group 5 is called the nitrogen family. It has a -3 charge because it needs to gain 3 electrons to get to 8, and it has 5 valence electrons. There's no plus there. Okay. So 5 valence electrons. Alright, group 6 is called the oxygen family. They have 6 valence electrons and they have a -2 charge because they have to gain 2 electrons to gain 8 as a whole. Group 7 halogens have 7 valence electrons and a -1 charge because they only need 1 electron in order to gain stability. Group 8 are called the noble gases. They have 8 valence electrons in the outside shell. They have a 0 charge. Some other vocab words you should know that associate with this group is that they are inert, which means non-reactive, or a full octet. Remember, octet refers to 8 valence electrons. 8, okay? 8 valence electrons. Helium is the only one that has 2 and has a full shell. Transition elements are our brown group. We don't talk much about them yet. And our inner transition metals are our white group. Okay, to summarize your main people when it comes to developing of the atom. The electron was first found. It was found by J.J. Thomson with the cathode ray. He used a plum pudding model. Now, most of us don't make plum pudding. So, if you've made chocolate chip cookie dough and you rolled it into a ball, the chips represent the electrons. That was the first idea of what the atom looks like. Okay? Then we have the proton, which was discovered by Ernest Rutherford. Remember, his experiment is called the gold foil experiment. He shot alpha particles into gold foil, and he expected it to basically go through or be attracted because he knew the electron was there. And in electricity, opposites attract, but like repel. What he found was that they came off at different angles than expected because he had a screen all the way around. And he was getting these bouncing back at different angles. It took him 2 years to figure out, since his alpha particles were positively charged, in order to get this to bounce back like it did, it had to hit something as dense or more dense than itself and bounce off of it or repel because it was like what it was hitting. So, because the alpha particles were positive, he figured out that there must be something in the center of an atom, a nucleus that contained a proton. Okay? James Chadwick in 1932 gave us the neutron. It was harder to find because it was neutrally charged. Alright, to summarize all of this, okay, to make this a little bit easier, we focused on the red area, the classical theory. Rutherford worked and found the protons with the gold-full experiment. He gave us a planetary model. He also shot his idea off of Chadwick. Chadwick and him worked together. Chadwick came up with the idea of a neutron. But the other player in this whole game was Niels Bohr. And Niels Bohr is like way famous, okay? Amazing guy, really smart, really brilliant. Okay, he knows his stuff in physics. And Niels Bohr was a student underneath Rutherford, and they didn't get along because, well, Niels Bohr kind of shot Rutherford's idea out of the water because he said, there's no way, it can't. Because in the rules of electricity, that proton should be attracted to the electron, so the electron should go BAM into the nucleus every time. And it doesn't. So there has to be something keeping those apart. And he asked, why would they even be running tracks? Because in Rutherford's model, it would run tracks like the solar system. And Bohr was like, no way, can't do that. Why would it do that? That makes no sense. So he gives us quantum theory, which we'll talk about later. All right, good luck on your tests. And don't forget, you're supposed to know Dalton's postulates and all previous knowledge. Have a great day.